In this Godot tutorial, I'll teach you how to make these floating damage values come out of your enemies or your player if you want to. Let's get started. So first thing we want to do is create that floating text scene that we can instance into the world. So I'm going to create a new scene. It's going to be a new 2D scene. Now immediately I'm going to change the type of this node 2D into a position 2D, as the position 2D is a little bit lighter in terms of performance, and we only need a position for this label, nothing else. We're going to rename it to floating text, and we'll add two children to it. One is going to be a label that will hold our actual damage value, and one is going to be a tween that we'll use later in this tutorial to fiddle around with the scale of the label a little bit. Now for this label, let's put a test value in here of 200. We're gonna go with a size rectangle of 100 by 25, but you might want to fiddle around with that size for your game. This just happens to be a good size for my game. Now we want to align both horizontally and vertically center to center, and I'm gonna lay out this label in the center of the scene so that whether we have 20 damage, 200 damage, 2000, 20,000, 200,000, 2 million damage, the value is always going to be in the center. That's important to have a good feel for it, else values are going to go to the right or to the left, and that doesn't look good. Now of course we want to change this rather ugly white standard font of Godot, so we're going to go to the custom fonts and we'll create a new dynamic font. By clicking on it, going to the font sub menu, we can then load a resource, and you can use your standard Microsoft fonts for this as well, and we'll load up our font. Now I want to change a couple of things here. First of all, I want a size 20, and I want it to have a little bit of an outline, and I'm going to use a filter to make sure that it's not so pixelated. Now with those settings set, I'm going to go for custom colors, and for the font color I'm going to choose this nice red. I've copy pasted that right in here, but yeah, you can just drag the cursor as well, or drag the crosshair to the color that you like. For the font outline, we're going to go with a pure black. So now we got a nice red black border 200 here. Now with this set, we have a scene that we can instance to our enemies whenever they take damage. So let's go over to the script and let's code this in. To make sure that our enemies are instancing in those floating texts, we're going to go over to the script of the enemy. On the top of the enemy script, I'll first be preloading the floating text scene. So call a new variable, we'll call it floating text. That is going to be the preload, and then between quotes we have here in the file system the saved scene floating text. We right click, we copy that path, and we paste it in there. Now by preloading the scene, the enemy always has access to that scene, and it's kind of handy because it's probably going to be spawning a couple of these labels in quite quick succession of each other, so it's handier to have that scene preloaded than having to load it every single time at runtime. So it's more performance friendly. Now I've closed all the other functions of our enemy and only left the relevant function open. That's going to be the onHit function. For those of you that have followed the combat series, this is probably something you recognize. I've only added these 3 lines of code. If you have not followed my previous tutorials, no problem. You probably have something like a function on the enemy or your enemies that is being triggered whenever the enemy takes damage, and you probably push a variable to it called damage. Now you might be doing a couple of more calculations here than only reducing the HP pool with the damage. You might also include mechanics like defense and all that kind of stuff, but at some point you have the final damage value that the enemy takes, and you want to push that damage value to the floating text scene so that we can put that in the label. So what we do is we create a new variable. This is going to be a new instance of floating text, and that instance we're going to call the variable amount, and we'll push the damage value to that. Now we don't have a script on our floating text scene yet, so we'll be adding that in a moment. So we got to make sure we have a variable amount there. Then lastly, third line, we are adding that child, this instance, to the enemy. As this is the enemy script, it will be added to the enemy, and that way it's immediately in the right position in the world, as it will be spawning on top of the enemy. Now with that done, we can switch over to the script of the floating text scene and make sure that that amount, that damage, is being pushed to the label whenever it spawns into the world. So over to the script of the floating text scene. We're going to go to the floating text here, and under the 2D position I'll add a new script. That's going to be empty, we create it, and I'm just going to be copy pasting a little bit of code. First thing we do is we define both the label and the tween. For now we only need the label, but the tween we'll be using in a moment. We also got that amount and we set it to 0 by default, but it will be receiving the amount by the script of the enemy as we've just programmed. Then under the ready function, we get the label and we set the text equal to the string of amount. The amount will be an integer and a label can only receive a text string. So we have to convert it to a string before this actually works. Now, when we play the game and we walk over to George and William here, we can now hit George and William and our label is being popped up. However, these labels are now staying here forever and they stay in the same position. There's probably a couple of labels on top of each other which we cannot identify one from another. So we have to do something with these labels to make sure that A, looks better, B, becomes more readable, C, that they disappear when we don't need them anymore. Let's start by making sure they pop out a little bit and disappear after they have done their job. To scale this property, we're first going to start with the starting scale. With the floating text positioned to the selected, under transform, we're going to set the scale to be starting at 0.7. Then with a tween, we'll make it pop out back to 100%, and then we'll make it go from 100% to only 10% before it disappears. To do that, we're going to be taking the tween, that is the reference that is right there, and we're going to be interpolating a property. That property, we first have to say, okay, where is this property located? Well, it is the scale property on the node itself where this script is on, so we can say it's on self. Then we need to tell him what property do you want to interpolate. That is the scale property. Then it requires the start of the tween, and that is simply where we just set it to 0.7. Then it wants to know where does it need to tween towards. Well, scale has an x and a y. That means it is a vector 2. So we're going to scale to a vector 2, and we're going to scale back up to 1, 1. In other words, 100%. Now it needs to know in how much time do I need to scale this up. Well, you need to scale it up in 0.2 seconds. Then it wants the type of tweens that we want to use, and for this case I'm going to go with a translinear ease out tween. And now we can close it off. With that done, we're now blowing up this tween or this label from 70% to 100%. Now what we want to have happen is once it is 100%, it's probably nice to have it at 100% for like 0.1 seconds, and then we want it to go back down to only 10% of its original size. So we're going to do something a little bit simpler. We're going to interpolate a property. Again, it will be self. Again, it will be scale. We now only know that we need to start with a vector 2, 1, 1. As that is where the previous tween has interpolated it to already. Now with that, we know we can now scale it to a vector 2, 0.1 by 0.1. And we know we need to do that in about 0.7 seconds. Now we're gonna go again with a translinear and an ease out. And now you can also optionally give a last value. What is the delay for before this tween starts? And we're going to delay that with 0.3 seconds. Thereby the first 0.2 seconds we're blowing it up to 100%. Then for 0.1 second it will be that size. Then the second tween will kick in, and then within 0.7 seconds it will scale it back down from 100% back to only 10%. Now with those tweens set, we can now go tween and start. Now of course, once it's down back to 10%, we don't just want it to stay there. We want it to be gone, go away. We don't need you anymore. The tween actually has a signal, and that signal is tween all completed. That is exactly perfect for us because we want to delete this as soon as it's 10%. So with tween all completed, we're going to connect that to our script. And on this script, we'll simply say self free, and it will be gone. So it's going to execute these two tweens, and then whenever that is done, the signal completed will be given, and then we remove it from the world. So with that done, let's quickly play this game, see if this all works out as we want to. And now when we attack George, we see these values pop out of them. They're blowing up, they're going smaller, and they're being removed from the world. So that looks good, but what about if we want to heal? George is sometimes healing himself, but we don't see those healing values. How about we make sure that this healing function also calls the tween, and that we change the color based on whether it's a damage value or a healing value? Let's get started on that. To make this text color dependent on the type, we're first going to make sure that it knows what type it is. So we give it a new variable called type, and for now at the beginning of the script this can just be an empty string. Now as soon as we set the text of the label, we'll match the type with either heal or damage, and depending on which of the two types it is, we'll set the custom color, font color, to the color that we want to. This is the red that we chose earlier for the damage value, and this color is a nice green. If you want to figure out which of the color codes you should take, you can simply go to the label itself. You can go into the custom colors, and by simply dragging the cursor to whatever color you want it to be, you see this color code change right there. Simply pasting and copy pasting that code into the actual script will set the color to that specific color. Now going back to the script of the enemy, we gotta make sure that George tells the floating text of what type it is. So we have to again refer text, we have to set the type, and under the onHit function we're gonna call this damage, as the match command is looking for that. Now with that said, we're gonna select these 4 lines of code, and as you can see I've also opened up the function onHeal. So as soon as George has healed, we'll also take a floating text, where now the text amount is not damage, now it is the heal amount, and the type of course is of type heal. Now when I play the game with these couple of changes, George will also be showing a floating text value as he heals himself, and he'll show those in a different color. Now it's still a little bit hard to see because all these values are popping exactly on top of each other. So what we'll do next is we'll add a randomizer, which will let the value float out randomly from the left to the right. Let's get started on that. Now to make our labels jump around, all we gotta do is give it some velocity. So on the top of the script, we first define a new variable velocity, and that is going to be of vector 2. For now, we'll set it simply to 0 by 0. What we want to do next is randomize the value for the x, what is jumps to the left or to the right, and anything in between. To do that, we're first going to be randomizing the seed, so the outcome of this function is going to be different every time. We define a new variable called side movement, which is going to be a randomization function of 80 minus 40. This randomization function works, or we can better explain it by going to the documentation. We first ran the percentage 81, that's going to give us a random value between 0 and 80, 81 minus 1, and then we can deduct 40 from it, thereby the end result is going to be either anything between minus 40 and positive 40. Now we redefine our velocity vector right there, and we tell it's going to be for the x axis, or the x movement is going to be the side movement, so whatever this random function came up with, and for the vertical velocity we can say it's 25 or 50 or however much you want. If you want your text to jump more to the left than the right, simply reducing, for example, 41 back to 80 to 40, and then with half the amount change the minus value. So we just deducted 40 from 81 and we deduct 20 from 40. So that's how you can randomize or change the behavior of this jumping left and right however you want. Next, to make sure that we use that velocity, we define a new function that's going to be the default function for the process, and we're going to say that the position of this floating text is going to be the minus is velocity times delta. Now on every frame, we'll change the position of this sprite a little bit based on that velocity. So if I would take this ice spear now and I would shoot down this target, you can see that now the values are jumping randomly left and right. Now also the values are moving up. If you want to change that, you can simply go back to the script, and from this minus, all you gotta do is make a plus. If you want more side movement, I don't know, add 120 or 80 here, add another 40 there. And right now we've just changed the characteristics of our floating text value to have more movement, and as you can see now the values or the numbers are moving down instead of up. So it is as easy as that to change the text label to your liking. But you can even go beyond, because what if you have critical hits? In most games where you have these sort of floating damage values, critical hits are even more stronger in the face. They're even bigger than your normal damage values. How do we do that? Well, that's quite simple. Right now our vector 1-1s here, that is going to be the scale and thus the size of our label, are hard-coded. What if we make this variable? So we define a new variable max size, and we simply define that as to be the vector 1-1, the default value. Now we can change this vector 1-1 on here and the vector 1-1 there to be max size. Now we made this variable. In the code nothing changed, but what we can do now, if you push the type critical to this scene, we can say that, okay, the match command, if critical, in that case you have to take the max size, and the max size you have to change to maybe 1.5. So now the scaling size here will take the max size of 1.5, so it will tween from 0.7 to 1.5 and from 1.5 back down to 0.1. You may also want to add, of course, a color to your critical hit. Maybe you want your critical hit to be red, and maybe you want your normal damage value to be a nice orange. Maybe you also have other types. Maybe you have something along the lines of poison that you want to be a nice green. Maybe you want your dots damage over time, or your hots, your heal over time, to have a different value. You might even want that your healings goes up and your damage values go down. It's all possible. This node is very flexible, this code is very flexible, you can change it however you like. And not only is it flexible in the behavior that it shows, you can very easily add the script that we added to our enemies also to your player. When your player takes damage, when your player heals, you can even add the call to this script on a crate or a barrel that you destroy in the world. When that barrel maybe has loot, you can even float the damage values above that. So this node is very flexible. You can very easily call it from any location, and you can change how it looks and how it behaves quite easily to fit exactly what you want. So I think with this script you are good to go on some floating text damage values. That was it for today, guys. Hope you like it, and if you did, smash that like button, hit subscribe, don't forget that little bell icon to make sure you don't miss out on the next tutorial. Now I also live stream my own game development on Twitch every Tuesday and Thursday. We usually get a big group of people in there, mostly Godot game developers, who chat, discuss and learn Godot together. I hope to see you there one day. If you would like to join, schedule and link down in that description box below. Hope to see you there. Until then, keep on gaming, keep on coding. See you later.